Hey guys, let's take a look at 2.6, graphing rational functions, part one. We are going to do again, rational function, as in I've got some polynomial over another polynomial. Just reaching back to a couple weeks ago, we had a parent function for 1 over x. So I'll just draw that off to the side here. All right, and this function had an asymptote on the x-axis, and it had an asymptote on the y-axis. And it had these curves that got closer and closer to the x-axis as I get further to the right. And then I would get closer and closer to the x-axis as I get further away from 0 on the left. Okay, it's a nice curve. So there's your 1 over x function. This particular graph is not just 1 over x, it's 1 over x minus 2 and then plus 1. These were transformations. So the negative 2 is going to shift the entire graph to the right by 2. And then this plus 1 is going to be another shift, or a translation. It will shift the entire graph up by 1. Okay, so I'm going to then take these asymptotes from my parent function, and I'm going to shift those down to, right to, which means that vertical asymptote, if I shift that to the right by 2, it ends up over here at the positive 2. And then I'm going to take my other horizontal asymptote, and I'm going to shift that up 1. Okay. All right, nothing else has changed, so this still approaches the asymptote. In fact, I think I should hit the point 1, 0. And I say approaches, it does not cross the asymptote, it just gets really close to it. All right, and then this will hit the point 3, 2, and again, it'll have the same shape. It approaches that asymptote and doesn't actually touch it, definitely doesn't cross it. All right, so it says identify the asymptotes and the domain. Okay, so as for my asymptotes, it has to do with these transformations. Because I shifted to the right by 2, this asymptote is at the x equals positive 2 line. And then the horizontal asymptote is going to be y equals something. In this case, we shifted it up 1, so it's y equals 1. So those are the two asymptotes. And then the domain is going to include everything, all x values. Domain is all about x values, and it hits every x value except for this asymptote, which was at an x value of 2. So there's a couple different ways you can write it. If you want to do it as an interval, you would say negative infinity up to the 2, do not include it, so parentheses, and then everything from 2 to infinity. Or you can say it's all x values except for positive 1. Another way to say it is you can say that x does not equal except for positive 2. So you can say x does not equal that positive 2. So a couple different ways to say the same thing. Take a look at what your homework wants you to answer it like. These are all pretty much the same thing though. All right, and then I added on to this the whole describe the behavior of f near any excluded values from left to right. So my excluded values, if I'm going left to right, I'm talking about x values, and I excluded this asymptotes. So I excluded the x value of 2. So I'm going to kind of apply that to what I have here. I'm going to fill in the blank. F of x, or in other words, my y values, go which way, up or down? As x goes to 2, this means x goes to 2 from the negative side, like from the left. So as x is approaching 2 from the left, it looks like it's going down forever to negative infinity. So I will say f of x or y goes to negative infinity as x approaches 2 from the left. And then this one I'm going to look at x approaching 2 from the right. So here's my x value of 2, and from the right it is going up to positive infinity. So I will put f of x, or my y, approaches positive infinity as x goes toward 2 from the right. Okay, so let's take a look at pretty much the same thing. Let's try it again. If you guys want to just push pause and see if you get it, and then we'll check and see what you get. In this case, I'm going to do a shift. It looks like we shifted to the right by 4. Excuse me, to the left by 4. Plus 4, so left. And then the minus 3 here, this one is going to shift our whole graph down 3. All right, so I'm going to draw these asymptotes where we're talking about. I went down 3, so my horizontal asymptote is down at negative 3. And to the left by 4, so my vertical asymptote is over here at negative 4. All right, and I'm going to extend this a little bit so that I can show my graph. So I should hit this point, what is it, negative 3, negative 2, at that point. And then I am approaching the asymptote, never crossing though, and it'll curve really sharp and approach that vertical asymptote but never cross it. All right, and here's another point that I hit, and I'm going to then make it approach that vertical asymptote, never touch it though, and the horizontal asymptote as well, approach it but never cross. Okay, so sketch the graph, identify the asymptotes and the domain. So the asymptotes, they have to do with my shifts, my transformations, translations. So that means I've got this vertical asymptote at the x value of negative 4, so x equals negative 4. And then I've got this horizontal asymptote at the y value negative 3, so y equals negative 3. Okay, those are my two asymptotes, and then the domain, again, there's a couple different ways to say this, but domain has to do with x values, and it looks like I hit every x value except for where the asymptote was, which was at the x value of negative 4. So I can either say negative infinity up to negative 4, and then negative 4 to positive infinity, pretty much everything except for the negative 4. I could also say that x does not equal the negative 4. It's everything except for that x value. All right, and then they will, I think on your homework, have you do this fill in the blank for the asymptotes. So f of x approaches at this vertical asymptote. I'm going to talk about what it approaches as my x goes toward 4 from the left. So x approaching 4 from the left right here, it was going down, 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 down forever. So I would say to negative infinity in this case. And then f of x approaches either positive infinity or negative infinity, like it's going either up or down, as x goes toward 4 from the right. So as I'm going toward 4 from the right, it is going up forever, so to positive infinity. All right, there we go.